Let's take a look at this question on the topic of circle from Catholic High. The points P -4, -1 and Q -4, 9 lie on the circumference of a circle C1. The line y equal to 17 is a tangent to C1. Given further that the x coordinate of the center of C1 is positive, find the equation of C1. Now let's think about equation of circle. We need two information to form the equation, center and also radius. Now we're not given these two information directly from this question, but we will be able to figure it out based on the information given. Now let me just place the information that's given to us on the coordinate axis. I have a point -4, -1. Let me just put a dot here. And since I have point Q as -4 again, I'll have a point vertically above point P. Let me just dot here. I'll have point Q as -4, 9. So now what you notice is that these 2 points must be on the circumference of circle. There will be two possible ways for me to draw the circle. One is around here and the second one is roughly around here. So you need to pay a bit more attention. We are given that the x coordinate of the center is positive. So my circle should be around here. So let me just draw this one here. And now let's link P and Q together because this will form a chord. And we all know that perpendicular bisector of chord will then pass through center of circle. So let me just put a dot here. Perpendicular bisector of the chord will pass through center of circle. Let me label it as C. Now I know that I can find the y coordinate by doing a midpoint of the y coordinate. So 8 divided by 2 will give me 4. Let me just place x, 4 into my diagram here. Next, I will have to make use of the tangent that's given to me, which is y equal to 17. Let me just draw somewhere here. This is the y-axis. So this will be the tangent of the circle. Y equals to 17. Now the tangent will touch the circle vertically above this center C. So you notice that this line will form the radius of circle. If I'm going to extend this line here, and I'm going to label it, it's going to be y equals to 4. Now notice that you can find the distance here. 17 minus 4, the radius here is going to be equal to 13. Now let's just keep in mind that we can draw radius at different positions as long as you link center to a point on the circumference, which means if I'm going to link this point Q to center, this one will also be radius of circle, which is 13. Now let's take a look at the right angle triangle here. I have this one is 4 and this one is 9. So the vertical height here will be 5. Okay, so this one is also 5. Now I'm going to make use of the right angle triangle to help me find the base of the triangle. So I'm going to do square root of 13 square minus 5 square, which I'll get 12. So I know that this base of triangle is going to be 12. And then I will find this value of x by using this dot here, which will be having the x coordinate as -4. So x value will be -4. Going to the right, so adding 12, I'll get 8. Okay, so I now know center of circle will be 8, 4. And since I already know radius is 13, we can use these two information to now form the equation of circle. So equation of circle will be x minus 8 square plus y minus 4 square equals to radius square. So 13 square will give me 169. So that's part A of the question. Now let's take a look at part B of the question. Find the equation of the tangents of C1 which are parallel to y-axis. So we know y-axis is vertical, so the tangent is going to be vertical lines. Now let me just draw the vertical tangent here, touching the circle at this point and also at this position here. So what you notice is that from this dot here to the center, this is going to be radius as well. This one to this one is going to be radius, which is 13. So to find it, we already have the x coordinate as 8 just now. Let me put it in here, 8, 4. So what you're going to do, I'm going to extend the line here. I know this line is x equals to 8. I'm going to go to the right hand side, so I'm going to add 13 to find this equation of tangent. So 8 plus 13 is going to be a 21. Then I'm going to go to the left by doing minusing the radius of 13. So 8 minus 13, this vertical line will take the value of x equals to -5. So question B, the answer for the tangent will be x equals to 21 and also x equals to -5. Part C of the question, a second circle C2 has its center at P, given that the ratio of the area of C2 to the area of C1 is 1 to 9. Find the equation of C2. So again, to form an equation of the circle, we need center and radius. So in this question here, we already know the center is P. So I'm going to write P down for part C. I know the center of the circle. I'm going to use P, which is -4, -1. So what I need is the radius of circle, how we are going to use the ratio of the area. So now let's take a look at the area ratio that's given to us as C2 to C1. That is 1 to 9. We're going to translate into ratio for the radius C2 to C1, okay? So what we're going to do is going to square root these two numbers. Square root of 1, you get 1. Square root of 9, you get 3. So the radius ratio will be 1 to 3. And since we know the radius just now for C1 is 13 unit, so this one here, it will be 3 times less than this. So this one will be 13 over 3 unit. Now, since we already know the center and also the radius of circle, now we are able to form the equation of the circle C2. And the equation will be x plus 4 squared plus y plus 1 squared equals to radius squared. So squaring these two numbers is going to be 169 over 9. That is part C of this circle question.